what this plot has done is we've taken the point of averages and gone plus or minus 1 standard deviation above and below the point of averages, both in the x direction and in the y direction. Okay? So this is just kind of carving out a chunk of data in the middle. We can start to think about summarizing bivariate data, but bivariate meaning 2 variables. So in this case, we're looking at quantitative and verbal GMAT. We can summarize the quantitative GMAT by its mean and its standard deviation, and the verbal GMAT by its mean and its standard deviation. But that's not telling us anything about the fact that this thing generally tends to slope up, right? So what we're trying to get to now is a measure of association that tells us something about not just the variables individually, but how they're associated, how they behave together, how one tends to vary with the other. Now, association and causation are very, very different from each other. We're going to talk about that at length. But if thinking to this example, if I let's do this just really briefly. If I look at my first-year MBA GPA versus my undergraduate GPA, right? Typically, on the whole, with some exceptions, especially down here, people who did better tended to do better in the other, right? If I had somehow gotten one more question right on my final exam in statistics and that had boosted my GPA by a point, a fraction of a point, would that have caused me to do better in grad school? No. Okay. I mean, it's sort of, so changing one variable doesn't cause the other to change. We're just looking at what happened for these people. They got a certain undergraduate GPA, they got a certain first-year MBA GPA. We're not thinking about manipulating one, altering one deliberately and seeing what happens to the other. So we're looking at association, not causation.